Hello and welcome everybody to another episode of Paper Talks. Today we're going on a deep dive into DeepSeek R1, incentivizing reasoning capability in LLMs via reinforcement learning.
Right.
It's a mouthful, I know, but trust me.
Yeah.
You want to stick around for this.
What's so fascinating about this paper is it throws out the old AI playbook.
Okay.
You know, forget force-feeding these models mountains of data.
Right.
What if we just rewarded them for getting things right? Could we unlock true reasoning in AI through something as simple as a virtual pat on the back?
So that sounds like a radical idea.
Yeah.
In a nutshell, what did the researchers actually do?
They built two models.
Okay.
DeepSeek R10 and DeepSeek R1.
Okay.
DeepSeek R10 is like the ultimate self-learner.
Okay.
It's given a set of basic rules and then turned loose to solve problems.
Okay.
If it gets the answer right, it gets rewarded.
Oh.
Over time, it figures out how to actually reason its way to those solutions.
But how do they make sure that it's actually reasoning and not just stumbling onto the right answer?
That's where it gets really interesting.
Okay.
They carefully design these rewards to encourage the model, not only to get the right answer, but also to show its work. So to speak.
Right.
They wanted to see clear, structured reasoning steps.
Right.
Kind of like a student showing their work on a math problem.
So walk me through this DeepSeek R10.
Sure.
How does this self-learning process actually work?
So imagine you're teaching a dog a new trick. You don't explain the physics of sitting. You know, you just give treats for the desired behavior.
Yeah.
It's the same concept here.
Okay.
They use this clever technique called GRPO, which is basically a way of comparing the performance of different versions of the AI.
I see.
And then using those comparisons to guide the learning.
So it's like DeepSeek R10 has a built-in self-improvement system.
Yeah.
Always striving to do better based on its past performance.
Exactly. And what's remarkable is they didn't use a separate AI to judge its progress.
Okay.
It's all happening within the model itself. And as it learns, you can actually see its thought process becoming more complex. It starts generating more and more of these things called reasoning tokens.
Hold on. What are reasoning tokens?
Think of them as the individual steps in the AI's thought process.
Okay.
Each token represents a piece of the reasoning puzzle.
Gotcha.
And what's fascinating is that DeepSeek R10 naturally starts generating more of these tokens as it learns, indicating that it's thinking longer and harder about the problems.
That's really interesting.
Yeah.
So do they share any specific examples of this happening?
There's this one anecdote in the paper that the researchers call the aha moment. So in one of their experiments, DeepSeek R10 seems to realize that its initial approach isn't working, and it decides to reevaluate, almost like it's having a flash of self-awareness.
Hold on. Is that a direct quote from the paper? I got to hear this.
It is. They actually include a snapshot of the AI's output in Table 3.
Wow.
You can actually see it trying one approach and then kind of hitting a wall, and then suddenly shifting gears and trying something completely different.
Okay.
It's pretty remarkable.
Now, that's what I call a deep dive moment.
Yeah.
So this self-learning approach sounds really promising, but were there any limitations with DeepSeek R10?
It did have a couple of quirks.
Such as?
Sometimes its output was a bit messy. You know, it might mix languages or format things in a way that humans wouldn't find easy to read.
Yeah, I can see how that could be a problem if you're trying to actually use this AI to solve real-world problems.
Right.
So is that where DeepSeek R1 comes in?
Exactly. DeepSeek R1 builds on the foundation of DeepSeek R10, but adds a few key refinements.
Okay.
It's like taking that raw talent and giving it some polish and structure.
Okay. I'm intrigued. Tell me more about this refined model.
Instead of starting from scratch, DeepSeek R1 is given a little bit of a head start with some initial data. They call this cold start data.
Right.
It's carefully curated to give DeepSeek R1 a basic understanding of what good human-readable reasoning looks like.
So it's not about teaching DeepSeek R1 how to solve specific problems.
Right.
It's about giving it a sense of style and structure.
That's a great way to put it. It's like showing a budding writer examples of well-written essays.
Right.
You know, they might not know how to write a novel yet, but they get a sense of what good writing looks like.
I'm starting to see how these different stages build on each other.
Yeah.
So after the cold start, what happens next?
Then it goes through a similar reinforcement learning process as DeepSeek R10.
Okay.
But this time it's building on that foundation of good reasoning practices.
Okay.
They really focus the training data on tasks that require complex reasoning,
Okay.
like math problems, coding challenges, and logic puzzles.
So they're really putting it through its paces, making sure it can handle the tough stuff.
Right.
And how did it perform?
Incredibly well.
Wow.
In fact, it performed on par with some of the most advanced AI systems out there.
Really?
Which is remarkable, considering it's not relying on those massive data sets that we usually see in AI training.
That was pretty impressive.
Yeah.
But remember you mentioned that DeepSeek R10 had some readability issues.
Right.
Did they manage to iron that out with DeepSeek R1?
Absolutely. They actually added an extra layer of reward to encourage DeepSeek R1 to be consistent with its language use and formatting.
Okay.
They wanted to make sure that its output was clear, concise, and easy for humans to understand.
So it's not just about being smart, it's about being able to communicate that intelligence effectively.
Exactly. And they took it a step further.
Wow.
Once DeepSeek R1 had reached a high level of performance, they actually used it to generate even more training data for itself.
Wait, so the AI is teaching itself?
In a way, yes.
Wow.
They ran DeepSeek R1 on a bunch of prompts and then carefully selected the best, most accurate reasoning outputs to create a new data set. It's like having the AI review its own best work and learn from it.
Okay, that's a pretty clever trick.
Yeah.
So they're essentially bootstrapping the AI's learning, using its own successes to propel it even further.
Exactly.
That's really neat.
And to top it all off,
Yeah.
they gave DeepSeek R1 a crash course in everything their previous model, DeepSeek V3, was good at.
Okay.
Things like writing, answering factual questions, and even a bit of self-reflection.
Wow. They really threw everything but the kitchen sink at it.
They did.
So after all that training, they must have put it through some rigorous testing, right?
They did. They ran DeepSeek R1 through a final round of reinforcement learning.
Okay.
But this time they used a much broader range of scenarios.
Okay.
Not just those reasoning-heavy tasks. They wanted to make sure it could apply its skills in a diverse set of situations, more like what you'd see in the real world.
So it's not just a one-trick pony. It can handle a variety of challenges that's really impressive.
Yeah, one of the most exciting findings was that they were able to distill this reasoning ability into smaller, more efficient models.
Okay.
They took existing models like Qwen and Llama and trained them on DeepSeek R1's outputs.
Wait, so these smaller models could inherit the reasoning skills without needing all that intensive training?
That's exactly what they found.
Wow.
And even more surprising, this distillation technique actually outperformed directly training those smaller models with reinforcement learning.
It's pretty remarkable.
Yeah.
So they've essentially created a recipe for baking reasoning into AI.
Right.
And it doesn't require those massive supercomputers that we usually associate with cutting-edge AI.
That's what makes this research so groundbreaking.
Yeah.
It opens up the possibility of making this technology much more accessible.
Okay, before we move on, I have to ask.
Sure.
If this is all about rewarding AI for getting things right,
Yeah.
how do they make sure it's not learning to game the system? Finding loopholes or shortcuts to get rewards without actually understanding the concepts?
That's a great question. They were very aware of that possibility.
Right.
They call it reward hacking, and it's a real concern in reinforcement learning.
Yeah.
To avoid that, they intentionally kept the reward system very simple and rule-based.
Okay.
They didn't use any fancy neural reward models that could be more easily manipulated.
So it's like they're giving the AI clear boundaries and saying, stay within these lines, and if you get it right, you get a treat.
Exactly.
Okay.
And that approach seems to have worked remarkably well.
So this is all very exciting, but I'm sure there were some bumps along the way.
Oh, yeah.
Were there any approaches that didn't work out so well?
They actually tried a few things that didn't pan out.
Gotcha.
For example, they experimented with process reward models and something called Monte Carlo tree search.
Okay.
But those methods weren't as effective in this particular context.
So it wasn't just a straight shot to success.
Yeah.
They had to experiment and iterate and learn from their mistakes.
Exactly. And by sharing those failures, they're actually providing valuable insights for other researchers in the field.
Right.
It's not just about knowing what works, but also understanding what doesn't.
Well, I have to say I'm thoroughly impressed with what they've accomplished.
Yeah.
But before we get too carried away, I'm curious, did they identify any limitations with DeepSeek R1?
They did acknowledge a few limitations.
Okay.
For example, while DeepSeek R1 excels at reasoning,
Yeah.
it doesn't yet have the full range of capabilities of their previous model, DeepSeek V3.
Okay.
It can't do things like function calling, complex role-playing, or generating structured outputs like JSON.
So it sounds like there's still room for improvement, but it's a phenomenal foundation to build upon.
Yeah.
Anything else they highlighted as potential areas for future research?
One thing they mentioned was the language mixing issue.
Okay.
DeepSeek R1 is primarily optimized for Chinese and English,
Right.
which can lead to problems when dealing with other languages.
Sure.
They see expanding its language capabilities as an important area for future work.
That makes sense. A truly versatile AI needs to be able to communicate effectively across different languages.
Right.
Any other limitations that they pointed out?
Another interesting finding was that DeepSeek R1 can be a bit sensitive to the way it's prompted.
Okay.
They found that few-shot prompting, where you give it multiple examples, can actually hurt its performance.
So it's best to keep the instructions simple and straightforward.
That's what they recommend.
Okay.
They suggest using a zero-shot prompting approach.
Right.
Where you clearly describe the problem and the desired output format.
Gotcha.
Without overloading it with examples.
Okay, makes sense.
Yeah.
Well, this has been a fascinating deep dive so far.
Oh, it has.
We've covered a lot of ground.
Yeah.
From the initial concept of teaching AI to reason through rewards.
Right.
To the development of these two impressive models, DeepSeek R10 and DeepSeek R1. What are your overall thoughts? What stands out to you as the most impactful aspects of this research?
What's truly remarkable to me is that they've shown that it's possible to train AI to reason without relying on massive amounts of data.
Right.
And not only that, they've managed to distill that reasoning ability into smaller, more efficient models.
Right.
Which has huge implications for making this technology more accessible and affordable.
You know, it's funny. We often think of AI as this cold calculating machine.
Yeah.
But this research almost paints a different picture.
Right.
This aha moment, this self-learning, the evolution of its reasoning process.
Right.
It almost makes you wonder if there's something more going on under the hood.
It certainly raises some interesting questions about the nature of learning and intelligence, doesn't it?
It does. And that's what makes this field so fascinating.
Yeah.
We're constantly pushing the boundaries of what's possible, and who knows what incredible breakthroughs await us just around the corner.
Well, let's not get ahead of ourselves.
Okay.
There's still plenty more to unpack in this paper.
Okay.
What do you say we delve into some of the specific techniques they used and see what other gems we can uncover?
I'm game. Let's continue this deep dive and see what other insights we can glean from this groundbreaking research.
All right, sounds good. So, all right, let's take a closer look at some of the nuts and bolts of this research.
Okay.
One of the things that really struck me was how they designed the training process for DeepSeek R1.
Okay, break it down for me. What made their approach so unique?
Well, they were very deliberate about the type of data they used for each stage of the training.
Okay.
Remember how DeepSeek R1 starts with that cold start data to get a basic understanding of good reasoning?
Right.
They use a combination of techniques to create this data, including prompting other AI models to generate reasoning examples, and then having human experts refine those examples to make sure they were top-notch.
So they're essentially giving DeepSeek R1 a crash course in Reasoning 101 before they even start the reinforcement learning process.
And then during the reinforcement learning stage, they focused on tasks that really emphasized reasoning. You know, math problems, coding challenges, logic puzzles. Things with very clear right and wrong answers.
Makes sense. If you're trying to teach an AI to reason, you need to give it problems that actually require reasoning.
Right. And they didn't just reward the AI for getting the final answer correct.
Okay.
They also rewarded it for following certain formatting rules, which encouraged DeepSeek R1 to present its reasoning in a clear and structured way.
So they're not just rewarding the what, but also the how.
Right.
They want to see that the AI is arriving at the answer through a logical thought process.
Precisely. And this attention to detail is what sets their approach apart from some other reinforcement learning techniques. They wanted to make sure that DeepSeek R1 wasn't just finding shortcuts or loopholes to get rewards without actually learning to reason.
It's like they're saying, show your work. We want to see the logic behind your answers.
And that brings us to one of the most fascinating aspects of this research.
Okay.
Those reasoning tokens we talked about earlier.
Right.
Remember, these tokens represent the steps in the AI's thought process.
Right.
And the researchers were amazed to see that DeepSeek R10, that self-learning model, naturally started generating more of these reasoning tokens as it learned.
So it's almost like it's thinking harder and deeper about the problems as it gains more experience.
And it turns out that this ability to think longer, to generate more reasoning tokens, is directly correlated with its performance on those complex reasoning tasks.
Okay.
It's a pretty strong indication that they're on the right track here.
This is all starting to sound a bit like science fiction.
Yeah.
You know, we're talking about AI evolving its own thought processes,
Right.
generating its own training data, and even inheriting knowledge from other AI models. It's mind-boggling.
It is remarkable, isn't it?
Yeah.
And it really challenges our traditional notions of how intelligence works. It suggests that maybe we don't need to handcraft every bit of knowledge into these AI systems.
Right.
Maybe we can create environments where they can learn and evolve on their own,
Yeah.
much like we do.
Okay, before we go too far down the rabbit hole of artificial consciousness, let's bring it back to the research.
Okay.
You mentioned earlier that they were able to distill the reasoning ability from DeepSeek R1 into smaller models.
Right.
How exactly did they do that?
It's a brilliant technique, actually.
Right.
They took existing language models like Quen and Llama,
Right.
which are already quite good at things like language understanding and generation,
Yeah.
and they essentially trained them on the outputs of DeepSeek R1.
So instead of starting from scratch with these smaller models,
Right.
they're giving them a head start by letting them learn from the master reasoner DeepSeek R1.
Exactly. And the results were pretty astonishing. These distilled models, even though they were much smaller and less computationally intensive,
Right.
were able to achieve comparable performance to DeepSeek R1 on a variety of reasoning tasks.
So this opens up some really exciting possibilities,
Yeah.
right?
Yeah.
If you can pack that same level of reasoning power into a smaller, more efficient model,
Right.
it suddenly becomes much more practical to use this technology in real-world applications.
Absolutely. And it also suggests that the reasoning patterns learned by DeepSeek R1 are incredibly valuable
Right.
and can be transferred to other AI systems.
It's like they've unlocked a fundamental principle of intelligence, and now they're figuring out how to share that secret with other AI.
No, it wasn't all smooth sailing.
Okay.
The researchers were very transparent about the challenges they faced
Right.
and the approaches that didn't work out as well.
Okay.
They mentioned experimenting with process reward models, which are designed to reward the AI for taking specific steps towards a solution.
Right.
But they found that these models weren't as effective as they had hoped.
So it wasn't just a matter of finding the right algorithm and plugging it in.
Right.
They had to experiment, iterate, and learn from their mistakes.
And they also highlighted the limitations of their current models.
Okay.
For instance, even though DeepSeek R1 is great at reasoning,
Yeah.
it doesn't yet have all the bells and whistles of their previous model, DeepSeek V3.
Okay.
It can't do things like function calling, complex role-playing,
Gotcha.
or generating structured data.
So there's still work to be done, but it sounds like they've laid a very solid foundation for future research.
They have.
Yeah.
And they've even open-sourced their models,
That's great.
which means other researchers can build on their work and push the boundaries even further.
That's fantastic. I love it when researchers share their work like that. It really accelerates progress in the field.
I agree. Open collaboration is essential if we want to unlock the full potential of AI.
Okay, before we wrap up this deep dive, I want to make sure we touch on the broader implications of this research.
Okay.
What are your thoughts? Where do you see this technology heading in the future?
Well, this research has the potential to revolutionize so many fields. Imagine AI systems that can help us solve complex problems in science, engineering, medicine, you name it.
Wow.
AI that can assist us in making better decisions, designing new products, even creating art and music. The possibilities are truly endless.
It's exciting and a little bit daunting at the same time, isn't it?
It is.
We're talking about a future where AI is not just a tool, but a collaborator,
Right.
a partner in problem solving.
And that brings us to an important question for you to consider.
Okay.
If AI can learn complex reasoning through something as simple as reward and punishment,
Right.
what does that say about the nature of intelligence itself? Could it be that our own brains are operating on similar principles,
Right.
constantly seeking rewards and avoiding punishments as we navigate the world?
Wow. That's a really profound thought.
Yeah.
It makes you wonder if the line between artificial intelligence and natural intelligence might be blurrier than we think.
It does.
But before we get too philosophical, I think we need to take a closer look at some of the ethical considerations that come with this kind of technology.
Sure.
After all, if we're talking about AI that can reason and learn on its own,
Yeah.
we need to make sure it's doing so in a way that aligns with our values.
Absolutely. Ethical considerations are paramount in any discussion about AI.
Right.
Especially when we're talking about systems that have the potential to impact our lives in such profound ways.
Well, I think that's a great place to pause for now.
Okay.
We've covered a lot of ground in this deep dive.
We have.
And I think we've all gained a much deeper appreciation for the complexities and possibilities of this groundbreaking research.
Indeed. It's been a fascinating journey so far.
It has.
And I'm eager to continue our exploration in the next part of our deep dive.
You know, it's amazing to think we've only just scratched the surface of this research.
Oh, great.
There's so much more to explore.
Yeah.
So many avenues for future investigation.
Yeah, it's true.
One thing that really struck me about this paper
Yeah.
was how open the researchers were about sharing their work.
Right.
They didn't just publish their findings.
Right.
They actually open-sourced DeepSeek R1 and those distilled models.
That's a really important point.
Yeah.
By making their models and code publicly available, they're not only demonstrating a commitment to transparency,
Right.
but they're also fostering collaboration and innovation within the AI community.
It's like they're saying, here's what we've learned, now go out there and build something amazing with it.
Exactly.
Yeah.
And that's the beauty of open science.
Yeah.
When we share our knowledge and tools freely, we create an environment where everyone can contribute and benefit.
So if you're a researcher or developer who's interested in exploring the frontiers of AI reasoning,
Right.
you can actually download these models and start experimenting with them right now.
That's right. You don't need access to a massive supercomputer or a team of world-class engineers.
Right.
You can literally download these models onto your laptop and start pushing the boundaries of what's possible.
That's incredible. It really democratizes access to this cutting-edge technology.
It does.
And who knows what kind of amazing applications will emerge from this open collaboration.
Exactly.
We could see breakthroughs in fields like healthcare, education, finance, even art and music.
Yeah,
The possibilities are truly mind-boggling.
they are.
It's exciting and a little bit daunting at the same time.
It is.
We're essentially giving these AI systems the tools to think and learn on their own.
Right?
We need to be very mindful of the potential consequences and make sure we're developing this technology responsibly.
Absolutely. That's why ethical considerations are so crucial in any discussion about AI.
Yes.
We need to be asking ourselves tough questions about how these systems will impact our lives, our jobs,
Yeah.
and our society as a whole.
We need to make sure that AI is used to benefit humanity, not to harm it.
Right.
We need to be thinking about issues like bias, fairness, transparency, and accountability.
And we need to be having these conversations now, not after the technology has already been deployed.
Yeah.
We need to be proactive, not reactive.
Absolutely. It's our responsibility to shape the future of AI in a way that aligns with our values.
And that's a responsibility we all share.
Right.
Researchers, developers, policymakers, and everyday citizens all have a role to play.
Well, I think that's a perfect note to end on.
It is.
We've gone on an incredible journey today exploring the cutting edge of AI reasoning
We have.
and grappling with some of the biggest questions facing humanity.
It's been a fascinating deep dive, and I hope it's left you with a sense of both wonder and responsibility.
I know it has for me and to our listeners out there. I encourage you to continue exploring, to stay informed,
Right.
to engage in these important conversations. The future of AI is in our hands, and it's up to us to shape it wisely.
Until next time, keep questioning, keep learning, and keep pushing the boundaries of what's possible.
That's all the time we have for today's deep dive. Thanks for joining us, and we'll see you next time on Paper Talks.